Here we have a capacitor in an RC circuit is charged to 75% of its maximum value in 1.4 seconds. What is the time constant of the circuit? What's nice here is there should be a few things you should know. A capacitor in an RC circuit is charged to 75% to its maximum value. So it's charging. So you should instantly latch on to the fact that you want to use the increasing equation, or x is equal to x max. Ugh, that was terrible. No. X is equal to x max. That's still terrible. It's fine. Times 1 minus e to the negative t over tau. Or this is, and tau is equal to RC. So, and then we're given some pieces of information. The first part is 75%, but what are you realistically supposed to possibly do with 75%? If you think about it, this is the maximum it can be, and this is the modifier. So this has to be equal to 0.75. If this is equal to 1, then it's at its maximum that it can ever be at. But if this is equal to 0.75, it's at 0.75 of its maximum. So this part has to equal 0.75. So we can say, okay, well, 0.75 is equal to 1 minus e to the negative t over tau. You can do minus 1 minus 1 and say, okay, well, negative 0.25 is equal to negative e to the negative t over tau. Or 0.25 is equal to e to the negative t over tau. That piece of information has now been used. And it says it got to that value in 1.4 seconds. So we can plug that in as well. We go, okay, 0.25 is equal to e over to the negative, very important, over 1.4. And now we just solve. We only have one unknown. We can swing that over and go ln of 0.25 is equal to negative 1.4 over tau, and then we multiply tau over here. And that's just going to give you, if you go ln of 0.25 times tau, and then negative 1.4 divided by your other answer, you get times tau, and then negative 1.4 divided by answer. There we go. Sorry, cleared my calculator. Tau is now, I'm sure you already got the answer. You're like, what's going on? 1.0098, blah, 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 blah. Just keeps going. But 1.0098 is going to be roughly the time constant here. And that's your answer. It's really about knowing this equation and what it means that it's going to get to 75%. It means that this modifier has to be 0.75 times the maximum that it can be. Again, if this is at 1, then it's at 100%. If this is at 0.2, then this is at 20% of what it can be. But we're looking for that 75%. So 0.7, this part has to be 0.75. And once you realize that, the math becomes very easy very quickly. Now, for the next one, it says, consider a series RC circuit, which means immediately you should just picture, the R part, the C part, and maybe a battery. That should be it. Immediately you should lead to that in your mind. For which R is equal to 2 times 10 to the 4th. So 2 times 10 to the 4th ohms. And this is equal to 6 times 10 to the negative 6 farads. And E is equal to 20 volts. Find A, the time constant of the circuit, and B, the maximum charge of the capacitor after the switch is closed. Let's just start with the time constant of the circuit. Well, we know that tau, as I said before, is equal to RC. So, that's it. You're going to take R times C, so 2 times 10 to the 4th times 6 times 10 to the negative 6 farads. and you're just going to get 0.12, it looks like. 0.12. That's it. Done. On to B. Also, just about as fast. A little bit longer, though. Well, not really, actually. Q is equals to CV, and it's asking for the charge, maximum charge. So we're assuming it's going to absorb all of that 20 volts, which is perfect. Find the maximum charge of the capacitance, which goes, yep. So Q is equal to C. So C is 6 times 10 to the negative 6 farads, and V is 20 volts. And you're simply going to get 1.2 times 10 to the negative 4th coulombs. And that is A and B done. It's literally it. It's really just to check that you know the equations. For both of these, we only had one unknown. Just understanding the question.